Hello and welcome back to my RC channel. I'm Andy RC and today I'm going to be checking out the HGLRC Arrow 3. This is a brushless 3-inch racer with a difference because this is the 6S version. It does come available as a 4S version, but if you do the calculations, the specs between the two are exactly the same, and the only thing that changes is the kV of the motors. So this one has 2400 kV motors, where kV is the number of revolutions the motor will turn in 1 minute when 1 volt is applied to it without any load. So a fully charged 6S Lipo is 25.2 volts. If I times that by 2400 kV, that gives us 60,480 revolutions per minute. And at the same time, if I take 3600 kV and times that by a fully charged 4S, which is 16.8 volts, then we also get 60,480 revolutions per minute. You have to remember though that those figures are not taking into consideration the resistance of a propeller and the higher voltage sag of a 4S against a 6S Lipo that is as equivalent as can be to the 4S. So as soon as we start applying a resistance to the system, the 6S should come better off as it has a higher voltage range to sag within, but it's also drawing less current than a 4S Lipo would at the same RPM. Well, that's the theory anyways. So for the Lipo, I'm going to be using this 550 milliamp GMB 6S, which has an XT30 connector and is as equivalent as it can be against a 4S 850 milliamp Tattoo R-line Lipo that I would have used for the 4S model. The GMB Lipo is just 1 gram heavier than the 4S at 108 grams. I was surprised to see though that they have used an XT60 connector on the Arrow, because at the making of this video there are no suitable 6S Lipos at this size with an XT60 connector, so perhaps it's something that they are expecting from the future. The only thing I will say on that is that if we've been using these 4S Lipos with an XT30 connector on these smaller models, then the 6S should only do better on an XT30, even more as the power system should be drawing less current, and it's that which requires a thicker gauge wire and also a bigger connector. But when you do use a 4S with an XT30 on these powerful 3-inch setups, the Lipo can sag to 13 volts in its first punch, which could have something to do with the connector bottlenecking the system. But I also think that the model demanding too much current than what a 4S Lipo can actually provide also plays a big part of the issue, regardless of the connector being used. So with all that in mind, I can either desolder this wire and add my own XT30 connector. I don't think it would be a good idea to just chop off the XT60 connector and replace it with an XT30, because the gauge of wire that they have used is 14 and it would be too thick to solder to a XT30's terminals. Or I can do what I have done, and that is to make up an XT30 to XT60 converter adapter, and then if in the future they start releasing 550 milliamp 6S Lipos with an XT60 connector, I won't have to mess around to try that out. Now, this method could have some performance implications in itself, because a further connector can introduce more resistance into the system. It's why on higher end machines we stopped using bullet connectors on the ESCs, because it created a resistance. However, I still think it should perform well given the lower current draw of the 6S Lipo. So all of this brings me on to the weight. Now the manual says that both 4S and 6S models weigh 150 grams without a battery, but this guy is coming in at 179 grams for me, so if we then add the 108 gram Lipo to that, the model then becomes 287 grams, so it's above the 250 gram registration limit, which surprises me because that is the appeal with these 3-inch models. If you compare that to their last popular 3-inch model, the XJB145, which had an all-up weight of around 236 grams, then that is quite a difference and is well below that 250 gram figure. So why is the Arrow so much heavier? Well, first of all, the XJB145 has a unibody, whereas this has individual arms, so that requires more screws and more carbon. You can see that we've got 2 extra sandwich plates and what looks like a load of press nuts, but the carbon is also thicker, so the arms are 4mm thick, and every other piece of carbon on the Arrow is thicker than on the XJB145. We even have this front part of the top plate doubled up in thickness for extra support. But despite all of that, there doesn't seem to be any camera protection, so I'll mention that because I know it's a deal breaker for a lot of people. It's not a deal breaker for me because I'm sure I could manage to smash a camera up even if it had its own bodyguard, and it's usually the motors that take the biggest hits with the look that I have. But sticking to the subject of weight, we also have a circular polarized antenna which weighs 9 grams on its own, and that has its own SMA connector and 3D printed TPU mount, and don't forget the heavier XT60 connector as well. So if you want to try and get this one under 250 grams, you could remove all of that and replace the SMA pigtail with a linear antenna, as well as removing this top carbon plate. But it's 37 grams over 250 grams. So if you are after that 250 gram figure, you might have to look into using smaller lipos, which will affect the performance of the model for sure, whether it's 6S or 4S, which will then make you question, well, should I just stick with the XJB145? I mean, it's a fast model with a top speed of around 99 miles per hour, if I recall, and it's well under the 250 gram limit, and at this point it's most likely cheaper as well. So is this Arrow bringing anything more to the table? Well, let's take a look at the specs. The stator of the motor is slightly taller with the Arrow, so they are a 1408 against the 1407s of the XJB145, but other than the top pattern being different, they are still a naked bottom motor, but actually they don't have the protection lip that the XJB145 has. The props are the Gemfan Flash 3052, which are probably the most powerful 3-inch props that you can get, but the stack has changed to accommodate the 6S, so that's probably why it's also gone up in weight as well. So on both versions, the 4S and the 6S, it's using HGLRC's own FD445 stack. So the ESCs are a 4-in-1 32-bit this time, and they are 45 amp D-Shot 1200 capable ESCs, which is a little bit overkill if you ask me, if those figures are correct. For example, the 4S version with an 850 milliamp 95C LiPo will only be able to achieve around about 80 amps in total, but this system is saying it can handle 180 amps. And then when used with a 6S LiPo, its limit is 35 amp per ESC, so that's 140 amps in total, where my 6S LiPo's capability is only around about 55 amps. So yeah, in short, the ESCs are overkill for either choice. There is a low ESR capacitor attached at the back, and there's also a nice cutout in the frame for it. It's a 220 microfarad 35 volt capacitor, and for 6S I would usually expect the capacitor to be rated to 50 volt because voltage spikes can be double that of the input voltage. However, from looking at this ESC, it's got a lot of filtering on board in the form of ceramic capacitors, so maybe the higher voltage isn't needed for this capacitor. There is still a hell of a spark though when you plug the LiPo into the connector. The ESCs do have telemetry hooked up on the RX4, so the UART4. However, just like the F440 stack, it doesn't have an onboard current meter, so you can only get the ESC temperature and RPM from the telemetry. However, with Betaflight version 4's new RPM filters, this could prove useful. And that brings me neatly onto the flight controller, which is an F4 and has come flash with Betaflight version 3.55 with Omnibus F4 V6 as the target. And as far as I can see, the only settings it has flashed to it are the default settings that come with the stack. So it had everything set up correct in the port tab, and there's a spare UART set up for GPS if you want to go down that route. D-Shock 1200 was selected in the configuration page, but from there everything needed setting up, such as rates and PIDs were just default. The on-screen display had minimal things on there, so I had to set that up, and D-Shock commands wasn't selected, so you need to select that because there's no buzzer with this flight controller. So if you are not accustomed to Betaflight, then I would say that this one is not for you. So above the flight controller, we have got the TX20V2 VTX, which is interesting because when you buy the stack from HGLRC's website, the VTX is newer and it's using an MMCX connector. But this one is still the V2, so it's using a micro UFL connector, and it's switchable from 25 milliwatt up to 350 milliwatt via the TRAMP protocol. And that is working on this version of Betaflight, and the reason I say that is that there have been cases where this VTX hasn't worked with the TRAMP protocol on certain releases of Betaflight, and it just stops working. But on this release that it has come with, it is working with no issues. And as I mentioned earlier, the VTX then pigtails onto an SMA connector, and we have HGLRC's stubby antenna. So this is the bind and fly version and has come with an XM Plus receiver, flashed with the non-RSSI international version of the firmware. You can also get it as a plug and fly and also with a FlySky to a receiver. So lastly up front, we've got the Cadex Ratal camera with its 1.6mm lens. Now a lot of people have asked me to review this camera, so I might do that separately. But this one came set up in 16:9 mode, and I'm using 4:3 goggles, and unfortunately they haven't provided the little controller board to change any of the settings. Now luckily for me, I have one of these boards, so I could change the settings, but I think for the price they definitely should have included that. Apparently with the 1.6mm lens and in 16:9 mode, it will give a field of view of 180 degrees, which sounds crazy to me, but in 4:3 mode it crops that field of view down, so I'll be trying it like that. My only criticism of this camera so far is that it's pretty hard to see the options through the goggles unless you cover the camera up with a lens protector, which it does come with. The package also comes with a battery strap, which is just about big enough for this Lipo, and we have a pre-installed silicone mat to stop the Lipo from sliding, which I always like to see. You are given just one spare pair of props as well as some stickers, and we also have the manual for the XM Plus, and you're given a quick start guide, which isn't going to be much use at all if you are a beginner, but I would not call this a beginner model anyways. So let's take a look at some DVR footage, and straight away I'm noticing the voltage 24.8 volts as it sat there doing nothing. That is incorrect for a fully charged 6S Lipo. It should be 25.2, so the voltage scaling needs adjusting in Betaflight, which is easy to do but worth mentioning. So we've got a sunny and calm day here. Let's go for a speed run and see what the top speed is. So 105 miles per hour. Did you notice a little ripple through the video though? And that is the problem going up in voltage. You get higher voltage spikes, so when the ESCs are breaking you get a higher voltage spike, and that causes a ripple of noise through the video. So maybe this model does need a higher rated 50 volt and a bigger lower ESR capacitor to combat some of that noise. But let's look at the voltage sag on this run. 22.1 volts and 104 miles per hour. So it's actually a slower speed than the first run, but importantly the battery isn't sagging lower to the point of where you should be landing, and that's the problem with 4S. Even on your first speed run, the battery can sag to around about 13 volts, and you should be landing at 14 volts. So as long as we stay above 21 volts, then we should be getting better performance. So 103 miles per hour, and just crept into the 21s then, stayed into the 21s. It's worth mentioning as well at this point that despite this model being heavier, that it is faster than the XJB145, only by a small amount though, you know, it's not a huge amount, but I have put a lot of cycles through these batteries to make it fair, and I found that your quickest run is actually at the start of the Lipo, and then it just slowly deteriorates. So you saw that run 99 mile per hour, so matching the speed of the XJB145, and that is just the battery just deteriorating, but still well within operating voltage. So if we take a look here now, so 94 mile per hour, and we are hitting 21 volts. So at this point, 2.5 minutes in, we want to be careful really, and we could just nurse the Lipo a bit and just try out some of the tune. So this is my own tune that I just copied and changed slightly from another model, so I'll overlay that so you can check out those PIDs and maybe you could improve on them yourself. But you'll see the battery voltage has improved a little bit as I did a little bit of aqua, and the speed's gone up, so we're back to 96 mile per hour. So I guess you could say with 6S it's more consistent. Yeah, you start off with a bigger punch and the speeds do deteriorate slightly, but it's more consistent. The only problem is when to land, you know. We're coming up to 3 minutes there, and I'm seeing 21 volts, and all of a sudden, the Lipo will just drop off to a point where it'll just decrease rapidly. So we're at 20 volts there, and we really want to be landing here now, but I wanted to do a quick dive of this tree. You can hear the RPM die. So yeah, this was another battery that I did. Again, we're just getting under a 4-minute flight time, and I'm just nursing it at 20 volts there for a landing. So there you go, that is my review of the HGLRC Arrow 3. I'll put a link in the description if you wish to get one, as well as a link to my Patreon if you can afford to do so. And as always, thanks so much for watching. Please continue to subscribe. Cheers.